We are going to integrate the given function using partial fraction, and this belongs to case 1 where there are distinct linear factors. So in the given integral, you have 2 divided by 2x squared plus 3x plus 1. First of all, you have to factor the denominator. So 2x squared plus 3x plus 1. You factor that using any methods you like. That is equals to 2x plus 1 times 2 plus times 2 times x plus 1. You do not need to show any works for that. And then, how about the partial fraction? So what we are going to do next is, we are going to split up this fraction into two smaller fractions. Why? Because there are two distinct linear factors. Distinct means they are not the same. Linear, 2x plus 1 is a linear function, x plus 1 is a linear function. Alright, so we have 2 divided by 2x plus 1 times x plus 1, that is equals to, so we have a divided by 2x plus 1 plus b divided by x plus 1. Now, two frequently asked question, can I swap the position of a and b? Yes, you can. The order is not important, right? And then question number 2 is, there is a plus between the a and b, can that be a minus? The answer is keep that as a plus, because let's say b is a and b, they are constant value like 4, 6, -2, -3. So let's say b is -3, the negative will take care of the plus for you. So you always use a plus to split up the smaller fraction. And then the next thing, we are going to get a common denominator. Because if you only look at this side, the right hand side, if I back in algebra, if I ask you to add them, the first thing you see that they don't have the same denominator. So that's why you need to get a common denominator. So let's do that next. So 2 divided by 2x plus 1 times x plus 1. So for the first fraction, we have 2x plus 1. So the 2x plus 1 is missing a x plus 1, right? And then the b divided by x plus 1, that is missing a 2x plus 1. Let's put that in. So this one is missing a x plus 1 and then x plus 1. This is missing a 2x plus 1 and a 2x plus 1. Alright, they must be the same on top and bottom, 2x plus 1 on top and bottom. Otherwise, you are multiplying something other than 1, then you change the entire problem. And then the next thing is, you have to multiply the numerator. So let's back to yellow. So we have 2 equals to a times x plus 1 plus b times 2x plus 1. 2 is equals to ax plus a plus 2bx plus b. So you do a distribution, and then you group all the x and the constant together. So 2 is equals to ax plus 2bx, and then plus a plus b, and then this is for the x, and then this is for the constant. And then you might ask me, hey, there is no x on the other side. What do we do? So let's write another line. In this line, I'm going to factor out the x. So we have a plus 2b, and then factor out the x, and then a plus 2b, which is the constant, right? So since there is no x on the other side, what you can do is you can add a 0x. So 0x, so the 0 is going to equal to the a plus 2b, and then the 2 equals to the a plus b. So this step is called equating the coefficient. So equating the coefficient. So what's the result? We have x0 equals to a plus 2b, and then we have 2 equals to a plus b. All right, and then this is a system of linear equations, and this is a pretty simple system. If you subtract two equations, 0 minus 2, a minus a is gone, 2b minus a b, that is equals to b. So we get that result immediately. B is equals to -2, and then you plug it into either equation. I prefer the second one. 2 is equal to a plus b, so which is -2, and then a is equals to 4. So now I got a and I got b. So all you have to do is you put the a and b back to the very first line. So what we are trying to do before all these lines is we are trying to integrate this, right? From 0 to 1, 2 divided by 2x plus 1 times x plus 1 and then dx. And then on the other side, we have integral from 0 to 1, a divided by 2x plus 1 dx plus, we have to move this a little bit to the right. So I get myself some space from 0 to 1, b divided by x plus 1 dx. You plug in a, you plug in b. Okay, let's do the plug in a. A is equal to 4. And then b is equals to -2. This integral is very simple, right? So you let u equals to 2x plus 1, and then du equals to 2 dx, u equals to x plus 1, and then du is equals to dx, and then you will just get an ln. So the first one you get 1 over u, right? And then the second integral you also have 1 over u. So that is an ln. But at this point, you made it to partial fraction. I expect you to be able to integrate without doing any integration by parts, because I don't want to put the 0 and 1 in terms of u. So I will just do the integration without the substitution. Did I say integration by parts? It should be u substitution. So I have a 4, can't touch the 4 yet, and then 1 over that, so that will be 1 ln, absolute value, 2x plus 1. The absolute value is not optional, because 2x plus 1, you want that to be positive. And then what else? When you take the derivative of the ln, you have 1 divided by 2x plus 1 times 2. Where is the 2 came from? By chain rule, you also need to integrate the 2x plus 1. So when you integrate that, you get a 2. So that's why there is a 2. So to get rid of this 2, you have to prepare a 1/2 in front of the ln. And then for the second one, you have to prepare a 1 over 2 in negative in front of the ln. So that is ln, absolute value, x plus 1. And then for both, x goes from 0 to 1, from 0 to 1. So this, you have 2 times ln, you plug in a 1, 2 plus 1 is 3. So this time you can remove the absolute value because 3 is positive. And then minus 2 times ln1, and then minus 1/2 ln2, and then minus 1/2 ln1. So ln1 is equals to 0. ln1 is equals to 0. So this ln1 is gone, and this ln1 is gone. ln1 is just equals to 0. So overall, you have 2 times ln3 minus 1/2 ln2. And then this is your final answer. There is no need to approximate this. Okay, so that is the end of this problem, and that is also the end of this video. If you think I picked the best problem and provide the most clear explanation, like the video, let me know in the comment below, share the video for me, subscribe to my channel. See you all in the next one. Signing out for now.